Formula selection begins with meaning, not with hunting for familiar letters. Boundary language such as around, edge, or fence points toward perimeter or circumference. Coverage language such as floor, paint, or face points toward area or surface area. Space inside language such as fill, hold, or container points toward volume or capacity. Per language such as miles per hour or dollars per item points toward a rate. The question's nouns and verbs describe the kind of measurement before any numbers are used. Name the requested quantity in words before choosing its formula. Meaning narrows the formula list immediately. Perimeter and area can use the same dimensions but measure different things. A rectangular garden is 8 meters long and 5 meters wide. Fencing goes around the boundary, so use perimeter, 2 length plus 2 width. Grass seed covers the flat interior. Coverage uses area, length times width. The numbers 8 and 5 do not choose the formula. The requested measurement does. Boundary answers use linear units, while coverage answers use square units. Ask whether the problem traces an edge or fills a surface. Surface area and volume describe different parts of a three-dimensional object. Wrapping a box covers its outside faces. That is surface area, measured in square units. Packing material fills the space inside the box. That is volume, measured in cubic units. Outside coverage adds face areas. Inside space multiplies 3 perpendicular dimensions. Square units signal surface coverage, and cubic units signal 3-dimensional space. The object alone does not choose the formula. The task does. Rate problems connect a total quantity to an amount per 1 unit. A car travels 180 miles in 3 hours. Find its average speed. Speed equals distance divided by time. Miles divided by hours creates miles per hour. Substitute 180 divided by 3. The result is 60 miles per hour. The compound unit confirms that division was the correct operation. 60 miles each hour for 3 hours rebuilds 180 miles. Let the word per and the units guide the formula. Percent context usually separates a part, a whole, and a rate. Find 18% of $250. Percent amount equals decimal rate times the whole. Write 18% as 0.18. Multiply 0.18 by 250. The percent amount is $45. 45 is the part, not automatically the final price. 10% is 25, and 8% is 20, totaling 45. Label percent amount and final total separately. A familiar shape can tempt you toward the wrong measurement. Circular table has radius 3 feet, and the question asks for trim around its edge. Using pi times radius squared would calculate the tabletop's area. The word around requests the circle's boundary, not its flat coverage. Choose circumference equals 2 pi radius. Substitute radius 3 to get 6 pi feet. The approximate boundary length is 18.85 feet. A linear unit confirms the corrected formula choice. Area would have square feet, which cannot describe trim length. Use context and units together to reject a tempting formula. A short decision path makes formula selection repeatable. First, name the target: boundary, coverage, space, rate, or percent amount. Next, predict the answer unit: linear, square, cubic, compound, or percent. Then match the givens to the variables required by a candidate formula. Finally, reject any formula whose meaning or units do not fit. For flooring in a 12-foot by 9-foot room, the target is coverage and the unit is square feet. Length times width gives 108 square feet. A perimeter of 42 feet would answer a different question. Target, unit, givens, and rejection create a dependable choice. Use 4 questions before substituting into any formula. What quantity is the problem asking for? What unit should the answer carry? Which formula connects that target to the known values? Does a competing formula measure something different? Challenge: a cylinder is being filled with water. Should you choose circumference, surface area, or volume? Filled space means the interior, and the expected unit is cubic. Choose cylinder volume, pi radius squared times height. Context states the meaning, units verify it, and the formula completes the model.